For thousands of years, Mars was an untouchable mystery. We watched it as a distant red light in the night sky, completely out of reach. By the late 20th century, humans had successfully walked on the moon. We conquered our closest celestial neighbor. But Mars proved brutally difficult to reach. Early robotic probes launched by both the United States and the Soviet Union frequently disappeared into the void or smashed into the terrain. The red planet acts as a strict technological filter. It actively destroys poorly designed machinery, making a safe landing one of the hardest engineering challenges in human history. Getting there requires launching a machine on a 480 million kilometer journey that takes 7 months. And we can only make that attempt during a narrow window every 26 months when planetary orbits align. Because of those harsh constraints, a modern rover requires years of delicate construction in sterile cleanrooms. It costs billions of dollars to build a vehicle capable of surviving the trip. As you can see in this scale visualization, the immense distance introduces a severe physical limitation. A radio signal traveling at the speed of light takes up to 20 minutes to cross the gap from Mars back to Earth. That massive delay severs our ability to pilot the spacecraft. By the time Mission Control receives the signal that the rover has hit the top of the Martian atmosphere, the machine has already been on the surface, intact or destroyed, for over 10 minutes. Distance forces scientists to hand over total control to an onboard algorithm, turning a highly calculated approach into a blind drop. The moment the spacecraft arrives, it faces an inescapable physics problem known as the Martian atmospheric paradox. Looking at this simulation of the entry sequence, you can see the first half of the problem. The atmosphere is thick enough to create massive friction, spiking temperatures outside the heat shield to nearly 1,300 degrees Celsius. But the atmosphere is too thin to actually stop the vehicle. Even after enduring violent friction and deploying enormous parachutes, the spacecraft is still hurtling toward the dirt at fatal speeds. Surviving this environment requires a precisely timed, completely automated sequence of events. If a single charge fires a microsecond late, the mission ends. Scientists call this rapid, brutal descent the 7 minutes of terror. It takes exactly that long to plummet from space to the surface. The spacecraft hits the Martian sky at over 19,000 kilometers per hour. To bleed off momentum, it forcefully ejects a supersonic parachute. For early, lightweight landers, parachutes and giant bouncy airbags were enough. But a modern rover weighs over a ton, and airbags would instantly pop under its massive bulk. To solve this, engineers invented a system called the sky crane. As shown in this schematic, the spacecraft detaches its parachute and activates a powered descent stage, firing rockets directly downward. This rocket pack hovers above the dust storms and gently lowers the massive rover toward the ground on long nylon cables. When the rover's wheels sense solid ground, explosive bolts snap the lines. The descent stage throttles up and flies away to crash safely. Every step of this acrobatic drop must execute flawlessly without human intervention. A single miscalculation, and a multi-billion-dollar machine becomes a crater. Back on Earth, thousands of engineers sit in absolute silence, staring at screens, waiting for the radio waves to cross millions of miles of empty space. Then the critical telemetry data finally arrives. The signal confirms touchdown, and the tension breaks into sheer relief. Decades of theory, mathematics, and extreme engineering culminate in a perfect landing. Human logic beats the brutal physics of the solar system. Once the dust settles, the descent stage is gone, and the rover becomes a mobile laboratory. It deploys its sensors and powers up its camera mast to begin surveying the landing site. Its job is to slowly drive across this desolate terrain, analyzing chemical compositions and looking for the geological scars of ancient water. The rover uses high-precision drills to pull samples from deep within the rock, searching for carbon-based signatures that have been shielded from surface radiation for millions of years. These chemical patterns are the potential fingerprints of a world that once had stable water on its surface. Finding these signatures suggests that the planet Mars once possessed the specific ingredients required for biological processes to begin. Every drill sample is a test for the existence of a second Genesis. Every successful soil analysis narrows the gap between speculation and proof that biology is not exclusive to Earth. Every chemical test and every mile driven by these robots lays the critical logistical groundwork for an even larger ambition: sending human beings. Keeping astronauts alive there will require staggering resources, from advanced closed-loop life support systems to heavy radiation shielding. The technology we use today to safely drop a 1-ton rover is the exact foundation we need to eventually land massive, pressurized human habitats safely on the surface. Conquering the 7 minutes of terror was our crucial first step. It turned a distant red light in the sky